For the science fair, I chose a project related to environmental science, as I think this is important in protecting the environment nowadays. The project I chose is called Using Nanotechnology to Clean Up Oil Spills. Research question: can nanotechnology be used to clean up oil spills? Oil spills in oceans have created many environmental problems, including destroying ecosystems and endangering ocean wildlife. The current methods used to clean up oil spills in oceans today are by using skimmers in the water or using sorbents. These methods are very time-consuming and expensive. The purpose of this experiment is to see if using nanotechnology can be more cost-effective and time-efficient than the current method. Hypothesis, independent variable, dependent variable, constants, and control. For this experiment, I plan to use 3 drops and 6 drops of ferrofluid for my 3 trials. My hypothesis is, if you add 3 drops of ferrofluid, then it will clean up the oil more efficiently because this amount of ferrofluid won't oversaturate the oil. My independent variable is the amount of drops of ferrofluid. My dependent variable is how much oil gets collected from the magnet. The constants are the amount of water, amount of oil, petri dish, dropper, magnet, and same bag used to cover the magnet. And my control is 5 milliliters of oil, which is no ferrofluid added to the petri dish. Brief information about materials and procedure. The main material used in this experiment is ferrofluid, neodymium magnet, droppers, petri dish, graduated cylinder, gloves, oil, and water. Out of these materials, I bought some of them from Amazon and others were available at home. First, I added 5 milliliters of oil and 20 milliliters of water in a petri dish to simulate the oil spill in the ocean. I gently moved the petri dish up and down to simulate the ocean waves and circled the magnet around the petri dish 5 times. After collecting the oil from the petri dish using the magnet, I poured the remaining mixture in the graduated cylinder and took the remaining oil readings and noted in the table. I took the average amount of remaining oil from the 3 trials and used the formula to calculate the efficiency. Using the data, I graphed the results. Experiment pictures. These pictures are taken during the experiment. The first picture is showing the materials used in the experiment. In the second picture, the petri dish on the left is showing water and oil mixture as the control. Second petri dish is showing water oil with 3 drops of ferrofluid, and the petri dish on the right is showing the mixture with 6 drops of ferrofluid. The third picture is showing the remaining oil after it was collected by the neodymium magnet from the petri dish. Table and graph. The data taken during the experiment is shown on the table on the left, and the graph is showing the 3 test results and the average inefficiency. Data analysis. The data from the table shows that using 3 drops of ferrofluid collected less amount of oil than 6 drops. Therefore, the efficiency using 6 drops was more efficient. Interpretation. The results of the experiment showed that using 6 drops of ferrofluid was more efficient, proving my hypothesis incorrect. The data I received from this experiment could help give scientists an idea on how much ferrofluid they should be using in the ocean to clean up the oil spills. An error I came across during one test is not shaking the petri dish enough to simulate the ocean waves. For some of the tests, I shook the petri dish a little more than others. This error would minorly affect the results. Importance. The information I've got by doing this experiment could be helpful for scientists who are looking for new ways to clean up oil spills. This idea could revolutionize a new way to clean up oil spills. Ferrofluid could be implanted into little drones which could clean up the shore in record time and with high efficiency due to the ferrofluid. Secondly, there can be more research done on how to separate the ferrofluid from the oil, which then can be reused. This experiment is just the first step of many in showing the importance of this new method. With more resources and experimentation done on the larger scale, this could become the new standard for oil spill cleanup. Conclusion. My hypothesis was proven to be incorrect given the results I've gathered as 6 drops of ferrofluid was the most efficient. Due to there being more ferrofluid for the oil to be attracted to, more oil was collected with the magnet. All tests went smoothly, but I could have had more constant shaking of the Petri dish to simulate ocean waves way better, which could have given slightly more accurate results.